Hello students, my name is Sonal Das and I am a BE engineer in Electronics and Telecommunication Department from IIEST Shibpur. Today I am going to give you an introduction to the chapter Light. So, before moving into the chapter, you need to understand what is light. Light is basically a form of energy. What is energy? Energy is nothing but an entity which can not be created nor destroyed, but it can be converted from one form to another. So, this is the basic law guiding the energy of the entire universe. So, light is basically a kind of energy source that travels in the form of waves. Waves, as we can see, we have all gone to sea beaches and we have seen the structure of sea waves that crush the beaches. So, light is nothing but a type of wave. It traverses from the light source to our eyes in the form of waves. So, next we can say is that we can see the wavelength of light in different colors. What wavelength is, we are going to explain in the coming slide. So from here we can say that light means all light has a source. That means light is emitted from a particular place which then comes to our eyes or falls on a material. From that the light gets reflected towards to our eyes and we can see the object. So every light which is coming or which is reaching our eyes are emitted from a source. A source can be luminous and non-luminous. Luminous sources are those sources which can emit own light, and non-luminous sources are those sources which cannot emit their own light. Luminous sources means like tube light, sun, all these things, and non-luminous sources are those which cannot emit their own kind of own light. So, and we can say that some light has heat energy. That means it is a very easily we can experiment, like when a bulb is glowing, after some time if you want to touch the bulb, you can see that the bulb is heated. That means we can say that light energy gets converted into heat energy. As in the start of the slide I already told that energy is converted from one form to another. Similarly, when we touch the bulb, we can feel some heat energy. That means due to the light, some heat is getting developed. That means light energy is getting transferred into heat energy in that case. So let's move to the next slide and know more about light. What makes things visible? We must wonder that how can we see things? You must think that we can see things by our eyes, but if we close our eyes, we cannot see a thing. Or if we switch at night, if we switch the lights off in our room, can we see any object in the room? No, we cannot see. That means though our eyes are open, but we cannot see a single thing. That means not only our eyes are responsible for viewing, but other phenomenon is also coming into play. So first of all, eyes are really an important factor for us to see anything. Next is light which comes falls on a subject, falls on a thing. Suppose there is a completely dark room and you have a torch in your hand and you have some object in front of you, say a book. We switch on the torch and we only focus the light on the book. That means the book, the light which is falling on the book is getting reflected in our eyes, and as a result of it we can see the book present there. This explains our third point, that is reflection of light, which is a very important concept in viewing any object or anything with the help of light as well as our eyes. Now let's move to the next point. properties. That means, what is light composed of? What are the properties? What are the characteristics of light? First of all, light is an electromagnetic wave. Electromagnetic, the word itself is self-explanatory. That is, it has got electrical and magnetic field. And it is special because it can transmit energy and can travel through vacuum. What is vacuum? Vacuum is a place where there is no air. Since light is an electrical as well as a composition of magnetic wave, that is why it can travel through a space where there is no air. That means it explains that why light does not need any medium to travel. That is why sun, which is millions of kilometers away from us, and there is basically, it is beyond space and there is no air in space, since still we can get light energy on the earth. That is why this property helps light to travel through vacuum. So there is another property, which is light travels in a straight line. Matlab, light can never change its path and travel in a zigzag manner or anything. See, when I'm recording the video, if I put the hand in front of my face, you cannot see this eye, because light travels in a straight line. If light traveled in a curved path, then it would have made its way out and you could have seen my eyes. So this proves that light travels in a straight line. Next, light is a transverse wave and does not need any medium to travel. Transverse waves means the particles which comprises light travels perpendicular to the direction of the motion. You can see a wave here. Here the particles are forming a 90-degree angle to the direction of the motion of the light energy. Okay. So similarly, it does not need any medium to travel. Next. The velocity of light changes when it travels from one medium to another. The velocity of a light means the velocity of light changes when light travels from a denser medium to rarer medium, as well as from a rarer medium to denser medium, which we will read further in the topic, which will explain the refraction of light concept. Next, the wavelength of light changes when it goes from one medium to another. Similarly, what is wavelength? As you can see the wave in the picture, the distance between the two consecutive peaks of a wave gives its wavelength. The wavelength of a light changes as it travels from a rarer to denser medium or a denser to rarer medium, which is a part of the topic refraction of light, which we will be reading further in the chapter. Next, a very important concept of light is reflection of light. You can see a diagram where incident ray is the ray which falls on a particular substance. Suppose it's a mirror or a book, whatever. It's a plain book, plain surface book, where incident ray falls and a reflected ray is produced as a result of it. Remember, when you are having any diagram, when you are drawing any diagram related to light, please make sure that you give the direction of arrow correctly. Otherwise, the entire concept will get changed. So here, the incident ray is the ray which falls on a substance, on a material, on an object. And reflected ray is the ray which gets reflected from the surface of the object. Now, what is normal? Normal is a line which is 90 degree, which is perpendicular to the object. And what is angle of incidence? Angle of incidence is the angle that an incident ray makes with the normal, and angle of reflection is the angle which a reflected ray makes with the normal. Clear? Now, in the reflection of light concept, there are two laws which is guiding it. First is the incident ray, the reflected ray, and the normal at the point of incidence. At the point of incidence means where the incident ray falls on an object and from where the reflected ray gets out, and the normal. 3 points are coincident. So all the points lie on the same plane. This is the first law. Next, the angle of incidence is always equal to the angle of reflection. This is the main concept of the reflection of light chapter. Next, we'll go to regular and diffused reflection, which is a concept related to reflection of light. First is regular reflection. What is regular reflection? Regular reflection is mainly a type of reflection where angle of incidence and angle of reflection is always equal. That means the surface needs to be plane where the point of where the angle of incidence and angle of reflection are always same. Next, we'll go to diffused reflection. Diffused reflection means in which the angle of incidence is not equal to the angle of reflection. That is why you can see that the reflected rays are getting scattered away in any direction it likes. This mainly occurs when the surface is not plane, where there are ridges in the surface, where the surface is completely rough. That is why diffused reflection does not follow the law of reflection. Clear? Regular reflection is basically seen in mirror. That is why we can see our image completely clear. And irregular reflection happens in certain rough objects where we cannot see an image and it gets completely disrupted. I think I have explained it. So that's it for the video. Now for the next topics, we'll make new slides and we'll get into it. Thank you so much for giving your time.